Welcome to the channel Tribe. In this session of TTT Tribecast webinar, we are having Monika Sharma talking on Docker testing.
Our topic of discussion, which is Docker testing. Today we are going to discuss about how the testing strategy around Docker heavy application. And we are also going to discuss about how testing strategy evolves from the QA perspective, in which all the quality gates we are going to ensure that the quality is in place by putting all the quality gates. And when I say quality, it doesn't mean just UI testing, it also means the validation of its integrity and licensing. Some checks around vulnerabilities are also equally important. Okay, so basically in the further sections we are going to talk about security, vulnerabilities, uh, something about licensing, performance, and yeah, so everything around the quality. Okay, so we'll proceed further. But before jumping to the quality gates and different levels of testing, we first have to understand what Docker is and some terminologies around it in brief, so that everyone is in the same picture. Okay, so first, what Docker is. So, Docker is a containerization platform that packages your application and all its dependencies together in the form of a Docker container to ensure that your application works seamlessly in any environment. Okay, so in order to use Docker, we have to install Docker Desktop. I hope you can see this panel, this side. So here you can see Docker Desktop is running. So in order to use Docker, we have to install this, and after that only we can use Docker related commands. Okay. Next is Docker file. So a Docker file is a file used to build a Docker image to your specifics, in a sense that so first we have to create a Docker file. Okay, and Docker file is basically nothing more than a lines of code, and these lines of code will come into the action when we spin up the container. Okay, so we are going to talk about container maybe in the further slides, but it just contains the lines of code. It will help us when we are going to build the image, and after that when it's run into the container form, then we can use whatever we are doing in the Docker file. Okay, so as you can see on the screen, this is a very simple Docker file. It starts with from, and this is the image. Image is nothing more than it's a Docker image, Docker created image as alias. Alias here we have given as base builder. Okay, so it contains the URL from the URL. So in order for demo purpose, I have taken up the URL as Red Hat registry. It's a open source registry, you can also use it. Okay, and then after that there are certain commands to perform actions. For example, here line number 6 to 7, I'm setting up some variables. Then line number 9 to 13, adding some packages and libraries in this image. And then at the line number 15, I'm just copying one of the file which is called as changelog under /etc folder. Okay, so don't worry about it if some of the things are different to you. It's we are going to see how practically it looks like. Okay, for example, let's say this is my code base and this has this image, this Docker file. Okay, so it contains this URL from, we are giving it as an alias base builder, installing some packages, and then so it's a multi-stage Docker file. We'll discuss this maybe later. Okay, so next is Docker image. So what is Docker image? Docker image is a read-only template that contains a set of instructions for creating a container that can run on the Docker platform. Okay, so we have Docker file right now. Okay, and we can create a Docker image by using the command docker build, giving a path where your Docker file is located. In my case, Docker file is located under images, the language based images folder, and then Ruby image and 2.7 builder. Okay. So I'll navigate to that Ruby image and 2.7. That's it. And I can give a tag to this just to identify the image quickly. It will take a bit of time. So this tag is optional. It doesn't it is not mandatory to give a tag. It's completely optional. So one by one it will download the layers, and after that it will do all the actions which we are doing right now in the Docker file. For example, this installing the packages, it has installed these packages. Okay, and at the end it will create one of the sha it will create a sha id with, let's say here it starts with 791930. Now if I do docker images, so it will create image with this tag, and the sha id or the image id starts with 79193, which is exactly the same. Okay, so this is how the Docker file looks like, and plus this is how we can build a Docker image. Okay. Now the next part is how we can, make this Docker image into the action. Okay, so that is via Docker container. Some people call it as, we are going to spin up the container. We have to run the Docker image. Okay, so there are different terminologies around it. So Docker containers are running instance of Docker image. So it's not like you are going to create, single Docker image or single Docker container out of this. So suppose I have this Docker file, I can create n number of Docker images and n number of Docker containers, but it's not preferable because it will be the same image, it will be the same container, but it will occupy very larger amount of memory space. Okay, so I'll just a second. I will clear this. Okay, so now here, if you see, I have this Docker image built. Now, in order to spin up the container, I have to use the command docker run hyphen id hyphen hyphen remove. So I want to remove the container once I exit from this. Okay. So if I don't remove it, if I don't use it here, then I have to do it manually after that. Okay, so as you can see, this has started the command line of the container. So this is very internal to the Docker, and we can, do, or we can put different commands in this. For example, okay, let's say we are installing majority Ruby in this particular Docker file as it's Ruby based image. Okay, so let's check the version whether Ruby is installed here or not. Okay, so here with this command it verifies that okay, Ruby is installed. Now the container is in running state. I want to stop this, I want to exit from this, and that's it. After this, the container will be removed. Okay, so it won't be there in the memory space. So these are the basic terminologies around the Docker, and we are going to use it in the rest of the section. Now, we have discussed about Docker, but what has enabled us, to discuss so in depth about Docker? So, what is the problem statement we have faced, and how does it look like? Okay, so I have, in order to, maintain the confidentiality, I have taken up the open source platform, which is Red Hat registry, and this is the Red Hat registry. Let's say we have an application like this and we wanted to test it. Okay, so it just has a basic UI but not a prominent UI which is kind of functional in nature. which contains different flows. Okay, it just have a UI just to show that we have these images, and let's say how to get this image. That's it. Okay, now how are we going to test it if my UI looks like this? Okay, and apart from that, what if my code base looks like this, where it doesn't have any UI or backend, it just have Docker images, and that too with different languages, different OS based. Okay, so here if you see OEL, so OEL is Oracle Enterprise Limited, and UBI is Universal Base Image. Okay, so if we have different languages and different OS, and we have just, if we open one of the folder, let's say it just have Docker files, that's it. Okay, then how we are going to test it? And I mean, if our ecosystem as a whole looks like this, what are we going to do? Okay, so the problem statement in front of us has included that how we are going to test these base images. Okay, which is based out of different languages like Node, Go, Ruby, which is widely used in the community, not only dev community, but also nowadays QAs are using this base images to run their test. Okay. Now, after that, our second objective was to set the quality gates around this Docker heavy ecosystem. So these were the two objectives. Now, this was the problem statement, and I wanted to know from you guys that what kind of testing will it suit here, as in that what kind of testing we should add in order to achieve that we have put the exact quality gates. You can mention in the chats. Mm, It's okay if you want to mention something which is different. It's okay, you can give it a try. Okay, so yeah, regression testing. Apart from that, be open guys, because this is interactive session, and I really wanted to know your thoughts as well. Integration test. Okay, apart from that, it's okay, give it a try. Ports are open and listening. UI test. Okay, security. Correct. Cross browser test, functional testing, particularly access level test, vulnerabilities. Correct. Yeah, so yes, we are going in the right direction. This is what I really wanted, to let you guys think about overall quality perspective. So before jumping to the quality gate, okay, we first have to identify what can be our goals of testing in this. Okay, so what will be our very high level set of objectives which we should target from our automated test. Okay, first is to get the optimized Docker files and working images with no security vulnerabilities and lightweight images. Okay, so here if you see this optimized Docker files and lightweight images, these are two different context. Okay, so when I say optimized Docker file, it basically means that the Docker file which we have created in the code base here should be as per the best practices, as per the Docker standards. Okay, whereas when I say lightweight images, it comes to the performance of the image. Okay, so that we are going to discuss in the next sections. So now we have seen that what are goals of testing, but under which testing umbrella it comes. So it comes under infrastructure testing. So infrastructure testing is about testing the application runtime environment, which is a collection of building blocks or components that can be used for supplying functionality towards other application. It also includes testing of code that reads configuration values from different files in the framework. Okay, so it doesn't with infrastructure testing, it doesn't mean that okay, we just can test Docker as a platform. Okay, we can test Kubernetes, we can test Packers, we can test Terraform as well. And and its integration with different cloud providers like AWS, Microsoft Azure, and GCP. Okay, so we can use all these lot of platforms, and it comes under infrastructure testing. Okay, now we have discussed our goals of testing. What can be our levels of testing and how it looks like? Okay, so first we can start with static code analysis, then unit testing, contract testing, security testing, performance testing, and then end-to-end testing. Okay, so the notion for end-to-end testing, contract testing, the notion will remain the same, but we are going to, discuss how it's different from the other conventional projects. Okay. Then we'll start with the static code analysis. So for static code analysis, we are going to use Hedolint as a library. So Hedolint is a Docker file linter that helps for building best practice Docker images. Okay. So, irrespective of whether it's Hedolint or any other library in Mac, if you are using Mac, we can install it using Brew. And if we are using Windows, then you can install it as a separate application. But these applications are not too heavy; they are not going to be heavy. Okay. So I'll clear this. This is my code base. Okay. So I have taken, let's say, one of the Docker file, which is 2.7 builder UBI 8 Ruby image as a reference. Okay. And I want to run Hedolint over that, but let's make something else. Let's make changes. Let's say we have this. Okay. And then we can run the Hedolint with this Hedolint slash images, and yeah, this is the path to the Docker file. Okay, we have clicked on enter, and then we have got the warnings. Using latest is prone to errors. If the image will ever update, pin the version. Okay, so here why I'm getting this error is that because I'm using latest in my base image. Okay, so how Docker works is that it takes one base image as a reference, it builds or it adds some of the packages or some of the libraries over the top of it. So here I mentioned these libraries to install. Okay, so whatever action I am doing, it will build on the top of base image. Then again depends on which action I am doing, then it will keep on adding everything on the base image, okay, that we have used in the line number 1. Okay, so we can it's actually good practice to fix everything, to fix all the warnings which it is showing. So for now I'll just remove that and add the version. So this is the version details of this particular base image, and this is the lower level info. Okay, so apart from that, it has given me one other warning, which is specify version with DNF install. Okay, so it depends on the requirement. For example, my requirement is to always install the latest version of these packages, these specific packages. Okay, so one warning we have fixed, other warning I want to ignore because this is my business requirement to always fetch the latest package. Okay, so if I run the hedolint command again, okay, so here we have just one warning. Okay, so yeah, I think we can ignore this because this is my business requirement, and this is about hedolint. Now, there are two other ways to optimize Docker files with which is not caught by Hedolint. It's not suggested by Hedolint. So first one is combining multiple run command lines with 2 and multi-stage Docker file. Okay. So here I have combined these two command lines, as in that dnf install -y and these packages, and 2m% dnf clean all. Okay, next is using the multi-stage docker file. How the multi-stage docker file is: a multi-stage build allows you to use multiple images to build a final product. Okay, so here in the line number 1 we have one base image, line number 4 to 8, we have installed libraries on the top of that. Then line number 10, we have given alias of that base image after installing packages to Ruby, and we have worked on that over the top of it. Example, we have added some variables and then again installed some of the libraries. Okay, so at the end, we are just making that as final, Ruby base image as final. Okay. Now what we are achieving by using multi-stage Docker files. Now suppose if we don't do this at all, okay, if we have two Docker files and that shares the same context. Okay, so two Docker files with the same kind of context, and when we are going to build those images, okay, it is going to consume, quite a good amount of memory space. Okay, so here, if I go, if I mention, just a second, if I mention here in the command line Docker images. Okay, so here you can see it's 542 MBs. But let's say if you don't have just one image, you have tons of images, as in that 20, 25, maybe more than that. Okay, then your disk space will get occupied with this memory space. Okay, and apart from that, the maintenance will be tougher if we create multiple files of the same context. Okay, so this is the reason why it's suggested that multi-stage Docker file should be helpful. Okay, so this is all about how our static code analysis, how we should do static code analysis in Docker context, and what we are going to achieve with this. I'll clear this for now. Now we have unit testing. So unit testing, we are going to test a single unit of work in isolation. It means that first break the infra code into smaller modules and then unit test those. And another thing is that first we have decided that, let's say, we are going to write the unit test, but now what we are going to write, or what kind of test we should do at the unit level. Okay, and before that, why it is called as, these particular test as unit level, why not integration level? Okay, so here in this section we are going to just test everything for Docker file and Docker image. Okay, so this is the reason why we are going to write this test at the unit level. If this particular Docker file, Docker image has an integration with the cloud providers, let's say AWS or any other platform like Kubernetes, okay, then we could have written integration test as well. Okay, so we have to consider every test level, as in that what we should mention in the unit level, what we should mention in the integration level as well. Okay, so there are different kind of test which should be considered at the unit level: command test, environment variable test, file existence test, file content test, and license test. Okay, so let me spin up the container with the docker run hyphen id hyphen hyphen remove and the tag which I have given. Okay, so next is with the command test, we are going to identify with the command that, let's say, the packages which we are installing here, okay, is getting installed or not. For example, if I am installing down here as Ruby, okay, so ideally Ruby should be there. Okay, or let's say zip hyphen hyphen help, then it should be installed with this version. Okay, apart from that, I'll clear this for now. So these are command test. Next is environment variable test. Okay, so where if we are setting some environment variables, it should be set correctly. That we can check it with the help of echo. So it will output the same what it is stored in the variable. Okay. Now the next one is file existence test and file content test. So it is related to the files. So here in the line number 32, we are copying change log from the current folder to the Docker image under etc folder. Okay, so this is what the changelog looks like. It has some version, some comments around the same. Okay, and let's check. We can do this by cat and then change log. Okay, so we can see that the changelog exists with this content, which is exactly the same which we have here, which the same file which we have copied under etc folder to the Docker image. Okay, so this is about command test, environment variable test, file existence test, and file content test. We have license test as well. This will come into the picture when you work with confidential client and then they have license, they have certificates. Okay, so you can just like this, you can write a code to curl into those certificates and it will output in that way. Okay, so we can write the license test by using curl commands. Okay, next is till here what we have seen is that how we are going to write check these tests or what we are going to test at the unit level, but all of this is a manual process. We are going to automate it and we have to automate that in order to get the fastest feedback. So for this demo specifically, I have taken TerraTest because it's simpler to set up, simpler to implement. Okay, and what TerraTest is? So TerraTest is a Go library that provides patterns and helpers functions for testing infrastructure. With TerraTest below, platforms can be validated, which includes Terraform, Packer, Docker, Kubernetes, just a second, Kubernetes, AW, and different cloud providers, AWS, GCP, and Azure. So the basic requirement for TerraTest is that TerraTest uses Go testing library. To use TerraTest, we need to install Go. But apart from Go language, we can also write the test in Ruby as well as I think JavaScript. Okay. So in order to use TerraTest, we first have to initiate a Go project and then we have to install the libraries around it. Okay. So I'll exit from this container. I'll clear everything to have a clear picture. And then now I'm in my project location. Okay. So I'll initiate a Go project with github.com/your profile ID and your project name. Okay. Now after this, we can install libraries TerraTest with github.com/gruntwork -io modules docker. Okay. This will install the libraries which are required for Docker. It will take a little bit of time to install. Next, we have the setup ready, but after that we have to write the test code. Okay, so the TerraTest code, it consists of three sections. First, the package. Second is the import, which will import the libraries, and then after this the function, uh, in which we are going to write the same set of steps which we have done manually previously. Okay, so here it has installed these libraries. Now I want to install one more library for assertion, which is just a second, which is stretcher/testify. So it will install this library. Now, in order to write the test, I want to write this test in the unit test level under the Ruby images test. And then here I'll create one folder Ruby 2.7 underscore test dot go. Whatever the test name you are mentioning, it just have a convention of using underscore test dot go. Okay. So just to identify that it's a Go test, we have to use this extension. Now, after this, as we have seen previously, there are three sections: package, import. We are going to mention package Ruby, and then we are going to import the libraries here, the testing library, and then for assertion and something to for using TerraTest internal methods. This is for files. We want it for Docker. Okay. Yeah. So after this, the third section was to create a function. Okay. So for this, we are going to create a function, then test Ruby, and then in the brackets, we are going to pass testing context. And in this section, we are going to write the code for the same manual steps which we have done. First, we are going to give a tag. Let's say we'll give Ruby 2.7. Then after this, we are going to create one variable, build options, and then we are going to use Docker's internal method build option in order to pass the tags. Okay. So here we just have passed the tag. Just a second. Okay. So till here we have just passed the tag. We have configured that, okay, this variable is containing the tag name, which we have given here. Now we have to build the image. Okay. So that we can do. And before building the image in the manual step, we have provided the path to the Docker file, right? So we are going to give the path. We have to come out from the folder, then images. So we have the Ruby image in the image, language based image, Ruby image, and then this is where my Docker file is placed. Images slash language based images, then slash Ruby hyphen image slash 2.7 builder UBI 8. Okay, that's it. Now we have all the parameters ready. Okay, so now we are going to do docker dot build, and we are going to give path and the variable in which tags are stored. Okay, so now till here we have built the image. With this, we have just built the image. Now we have to write a code in order to run the command in the command line of the pinned up container. So for that, I'll create one more variable, which is options opts, and then it will again use the Docker internal method which is run options, and then inside that I'm going to pass the command, which is, let's say, Ruby hyphen v as well. It will work, and then I'll close this. So through this we are passing the command Ruby. Now we have output docker run t dot. So what this line is saying? So this is saying that we have to run the docker with this tag and with this variable which contains the command to execute. Okay. Now, yeah. Now after this, we are going to assert dot equal, and then we are going to pass the testing context, and then let's fail the test first, and let's say I'm giving a wrong version here, and then it will try to match with the actual text which will be inside the output. Okay, So yeah, I think that's it for this. I hope we have resolved all the errors. Okay. So I'll clear this for now. I'll go inside this folder, Ruby and Ruby. Okay. Now I'm going to run the test with go test hyphen v run test Ruby hyphen v hyphen run and then test Ruby. Okay. So it will do the same exact step. It will download the image. It will extract every layer and then it will build the image. After that, it will spin up the container. And after spinning up the container, it will execute this command ruby hyphen v, which we have given here in this section. Okay. So now the test has failed. The reason was that the actual thing, so this is the expected one. So this is the expected which we have given here, which is wrong, Ruby 2.6. And this is the actual thing which we have received. This is the actual version. Okay. So let's check that whether our test will pass. Okay. So we'll hit the same set of commands. This time it won't take much time. Okay, so it says that it has passed and it is able to match this assertion, which is having actual as well as the expected. Okay, so this is not just Ruby test, Ruby hyphen version, which we can check in the unit test section as I think if I go previously to the unit section, we have discussed command test, environment variable test, file existence test, and file content test. So we can check all those tests by writing those kind of commands here and making some modification in the assertions. We can use, if we don't want to match everything strictly, we can use assert dot contains as well. Okay, so that again depends on what go library you are using for test runner, for test framework as well. Okay, so this is about TerraTest, but what all are the available options, apart from TerraTest? First one is Gauss. So Gauss is kind of a subset of server spec. We can use Gauss, but the problem with Gauss is that um, we cannot use this in a case of Docker in Docker. Okay, so if in our pipeline it doesn't support Docker in Docker, for example, because of any to avoid the security issues, so there are few clients who doesn't support this, so that time we cannot use this. But apart from that, if you don't have that restriction in the pipeline, you can go ahead and use cause and TerraTest as well. So after that we have sh unit 2 and bats is bash automated testing framework. So these two are shell based, sh unit 2 and bats. It has inbuilt testing framework. You don't have to use or set up anything different. Okay, so you can prefer bats over sh unit 2 because sh unit 2 doesn't have reporting, and you have to create your own plugin just to get the reports out from the test. And at the end we have container structure test. So container structure test is created by Google. Um, it is very simpler to implement, very simpler to maintain, because these tests are written on the YAML file. Okay, and the problem with this is that it has a very less set of documentation. So in case if you want to do something else, something different, then you have to do research a lot. Next is we have talked about static code analysis, then unit testing. Now we have security testing. Okay, and in this section we are going to check for vulnerabilities, and for reference I have used this library grep. It's a vulnerability scanner for container images and file system. It works with Swift and the powerful SBOM tool for container images and file system. Okay. So, in order to show you this, clear, I'll expand this. Okay. And for now, I'll close everything. Okay. So let's say we have Docker images. Now we have Docker images. So this is the one which we have created manually, and this is the one which we have created with automation. Okay. So now I wanted to run the security check over my image, which is grep and then Ruby 2.7. So it will take a bit of time to extract every layer and to find the issues in that. Okay, and how it divides the security check is, first it will show the library which is impacted with the security issues. Second, it will show the vulnerability IDs, just like this. Well, the vulnerability IDs, the version in which this security issue is there, or is there any fixed version in which this particular security issue has been fixed, and the severity level, like whether it's low, medium, high, and critical. Okay, so it actually depends on the size of the image. If size of the image is too much, then it can take quite a bit of time. Okay. But apart from, maybe by the time it is loading, apart from this grep, what are the available options for security check? We can use Docker scan. It internally uses Snake, and it's this Docker scan. You don't have to install any other library. It just with the, if you have Docker, you can simply use Docker scan. There is Trivi and Claire. Trivi and Claire, they both give the same set of vulnerability issues. They both give the same set of vulnerability list. Okay. So if I scroll up, so this image has this many security issues with different severity level, low, medium, high. Okay. And just a second. Okay. So first, what it has done is that it has checking whether the DB is available, vulnerability DB. Then it has loaded the image, passed the image, then cataloged the packages. Then it has scanned the image. Okay, and then it has listed out that how many vulnerabilities are there. Okay, it will show that what is the name of the vulnerability, what is the installed version, whether it's fixable or not, what is the vulnerability ID it comes. Okay, and what is the severity level. Okay, so there might be some libraries which has a fixed version. Okay, and we can exactly check whether we can fix this immediately or not. So it, the ideal way is to fix all the critical ones, to fix the issues related to all the critical and the high severity ones, and then maybe depending on how much critical the medium vulnerability is, we can create a tech debt card, and then we can resolve it at the later stage. Okay, so this is for the security vulnerabilities, and this, I think, grep is the library which has indicated that, okay, the log4j vulnerability issue is there. Okay, so previously, in the previous maybe month or so, there was a lot of talk about log4j vulnerability, how it is impacting the customers, the confidential customers. Okay, so with grep, GRYP, so with the grep, we were able to catch the log4j vulnerabilities. Okay. The next is performance testing. Unlike the very conventional project where we are injecting certain scenarios with a certain number of users, and that can ramp up with n number of seconds or like that. So irrespective of what we do there, here the notion of performance testing is something different. Okay, so it basically with performance testing, we are going to validate the efficiency of images, validate how much space is getting wasted, validate the growing image size against the agreed threshold. Okay. So for this, what we are going to use, we are going to use Dive. This is again a library, the performance testing library, and we can give this image tag. It will again, depending on the size of the project, it can take that much of time. It will fetch the image, then it will extract every layer one by one. Okay, but apart from Dive, we haven't find any other alternative to this. It just maybe because of that, we have to rely on Dive for the performance. Okay, let's wait for a second, for maybe a second or two. So it is analyzing the image. Now it is building the cache. Okay. So you can see here it has said that okay, this particular the first line from this is taking 226 MBs, after that nothing, and then so it will extract each and every layer and it will find the size as per that. Whereas on the right side, if you can see under the etc folder, we have added the change log. Just a second. Okay, so these are the files where everything is added, and that too with the etc folders. It will show the file structure with these many size or the memory occupied. Okay. Whereas in this side, it will show the digest, the image information, and after that, it will show the image name, the total size of the image, potential wasted space, and image efficiency score as well. So here the image efficiency score is 83%, but so the ideal score should be between 80 and more than 90%. If it's below 80%, then we should look into it and we should, try to minimize this efficiency score. Okay, so next we have is the integrity check. Now we have checked that okay, our image is having comparatively no vulnerabilities and it is of good performance. It occupies less space in the consumer's local machine. Now we have to check that if a consumer is using these base images, okay, he should have a trust that okay, these base images are from a validated source. No one has hacked the base images and then published it with vulnerabilities. Okay, so that we can do with the help of Scopio. So Scopio is a command line utility that performs various operations on container images and image repositories. It can work with OCI image as well as original Docker images. Okay, so when let's say for Scopio, we can do Scopio inspect Docker, and as this image is local, I can either give the URL if it's in the remote, and if it's local, then I can give this command docker daemon and then the image name with the version. So it will take a little bit of time and it will show something like this, some image details and the labels as well. So the validated source will be having the label as, let's say, I'm using this image from the Red Hat Open Registry. So it is having some of the labels which is based out of Red Hat com.redhat.component com.redhat.license. Okay. So all this will indicate that okay, this image is from a validated source and they can they can use this image, they can consume this image, being a major consumer. Okay, so this
Monica,
is
we have
how.
5 minutes left.
Okay, so this is how it looks like. It has all the labels which will identify that Okay, this is from the validated source. Okay, now the next thing is pipeline, how we are going to set the pipelines if we have these tests. Okay, so we should run the pipelines, run the test in the pipeline to automate testing in order to get the immediate feedback. So let's say if a docker file is ready, it's good to push to the main repository. We can run unit test and contract test as a part of PR builds, and then uh, once it's merged to the main repository, main branch, then we can run our security test, performance test, and end-to-end test to the hosting platform like dockerhub.com or the artifactory. Okay, so here I mentioned the unit testing. So there is no separate library to use there is no separate library to use contract testing. We can use our contract test in the unit test itself. Okay, so how the contract test will look like, why, in what case we should write the contract test. Suppose I am using this base image. If this base image is internal to the client, then there is no need to write the contract test. But if it's external to the third party, for example, in this case, Red Hat, okay, then we have to write the contract test, but it will be merged with the unit test. Okay. Now the question is that will the strategy remain same for daemonless? Before that, what is daemon and daemonless? Okay. So Docker is daemon, and it basically means that there is one background process which keeps on running in order to use Docker. Okay. Whereas for daemonless, we don't need this background service. Okay, we can simply use it in the form of commands, and there are two libraries which gives this daemonless services, which is podman and builder. They both are same. They both are a tool that facilitates building OCI container images. They both can be either run as root or rootless or in rootless mode. They both are equally same. Okay, it just, let's say if you are using this command docker build and then image name, so instead of that you can use podman build the image name and build and the image name. Okay, so they are equally important. It's just a variation of the name. It just these podman and builder, they are daemonless. Okay, now the question is, uh, will the test strategy that we have discussed before, it will remain the same for daemonless? The answer is yes, it will remain the same, except the one section. In case if you are if you are doing security testing and if you are using docker scan, okay, and if you are using daemonless, then you cannot use this docker scan. But yeah, trivi, claire, and grep, it will work equally if you are setting this up in the pipeline. Okay, so as a recap, what we have discussed till now is we have discussed the very basic things about docker, some terminologies around it, like what docker build mean, what docker run mean, what spinning container mean. And after that we have discussed about a little bit about infrastructure testing, then different levels of testing, which just not include UI but the different perspectives from the quality gates. And after that, after discussing unit level tests, static code analysis, performance, security, and integrity, we have discussed a little bit about daemon and daemonless.